I think it's fair to say that most people that have some knowledge of paleontology are aware of the huge advancements paleontologists have made with the appearance of extinct animals, none of which are more impressive than color. The Jurassic Paravian Anchiornis is the first non-avian dinosaur of which we know almost exactly its palette. Comparing the fossilized pigments found in the feathers with those of modern birds, we now have an amazing view of what this animal most likely looked like. This method has been used on several other highly preserved animals, most of which are from China, but that's not what this video is about. I want to look at a less well understood and oftentimes overlooked aspect of dinosaur appearance, and that's the variability of color within the same animal. What I mean is all the different ways animals of the same species can look incredibly different from each other. It's something I never see talked about, and I find the subject fascinating. I'll demonstrate the different possibilities utilizing the prehistoric planet T-Rex, and at the end I'll create a final artwork to show off just how much we can do with this information. To begin, we can first look at the most well-known instance of wildly different colors, and that's mutations.
We're awesome! Bodacious! Yeah.
Mutations can often occur for the coding of an animal's colors, and these can be passed down with varying levels of success. The most famous instance of color mutation in an animal is that of the black panther. These are usually leopards or jaguars that exhibit the condition known as melanism. Melanism is when there is a significantly larger amount of melanin produced than is usually the case. Melanin is the pigment that creates browns, blacks, dull yellows, and dull oranges, dull reds, and grays. My dog is an example of melanism. Oh, you should a cutie pie. Melanism is most commonly associated with mammals, but reptiles, amphibians, and birds can also be melanistic. This is the example I've seen the most clearly in paleo media, with Path of Titan skins, a Hoops and Dynamite video, which was great, and others showing it. But how well can it relate to dinosaurs? In avian dinosaurs, melanism is the most abundant way birds differ in color. In fact, several different bird species were actually melanistic individuals of an existing one that wasn't really realized until a better view of genetics came forth. Melanism is often a favorable phenotype to exhibit, as black animals are generally easier to overlook and tend to have a better chance of survival. Melanism can also cause more variance than simply black animals. Partial or pseudo-melanism doesn't cause a uniform coat of dark pigment, but simply exaggerates existing patterns. Melanism is also caused by a variety of different genes. In some cases, the individual may not even be darker at all, and may even cause paler pigmentation than usual, but that's not really what you think of when you consider melanin. But it's a fun thing to know about. With the abundance of different groups that melanism affects, it's a well-informed bit of speculation to say dinosaurs may have also been melanistic from time to time. I imagine predatory dinosaurs would definitely benefit from a mutation like this. There is also a trend of convergent melanism found within marine reptiles. A mosasaur, ichthyosaur, and the leatherback sea turtle were all shown to have melanocytes dominated by high concentrations of eumelanin, which, of course, promotes melanism. Uniform black coloration can be advantageous for marine animals living a pelagic lifestyle, especially in deeper, darker waters where countershading wouldn't be as effective, which is obviously something to consider for marine paleo art. Another very well-known mutation is albinism. This is when there is an almost total lack of pigment within an animal. Common examples of albinism are the classic lab rat and lots of different snake morphs. Albinism is usually recognized by a white or yellow coloration and reddish eyes, but the eye color can vary. It has been found in almost all vertebrate species and has been observed for centuries in the wild. Despite how widespread it is, albinism is a way rarer condition for animals than melanism, being a recessive allele. Not only that, the majority of albino animals exist solely in captivity since their unique appearance is highly valued and often selected for. In nature, albinism has correlated to populations experiencing some sort of environmental stress or more isolated populations in general. An interesting example I found was that barn owls in the Chernobyl region apparently had an increase of partially albinistic individuals compared to other areas. And I find that really interesting, considering that that would totally be the cause for some sort of stress on the population. Perhaps areas with less fossil abundance and fewer individuals of a given species could have had higher levels of albinism. That is, if we ignore preservation bias and other things. Where dinosaurs are concerned, albinism may be exhibited differently among different genera due to its different ways of affecting birds and reptiles. Feathers are white in albino birds, while other reptiles vary from white to yellow. I've seen albino dinosaurs in multiple areas, including, once again, a Path of Titan skin. So yeah, I think it's a cool idea, but I feel like if you're going to reconstruct a prehistoric animal with albinism, it might be a cool bit of storytelling to make that animal more scarred up than you'd normally expect it, or like more scarred up than its compatriots, you know, since it's more obvious to predators and whatnot. Leucism is a partial form of albinism in which pigments are retained in certain parts of the animal, most prominent of which are the eyes. Many charismatic animals have leucism, including white tigers and lions. Leucism can be seen in largely increased frequencies among certain populations, just like albinism. I think the example that I find is most well known is the population of lions in Timbavati, where there's just so many of them that are just white lions, and they're a sight to behold. Unlike albinism, which is more of an umbrella term, only a single gene codes for leucism. A great idea for paleoart, and a possible bit of artistic contrast that I definitely want to apply, is an old Erythrism with its scaly parts having darkened with age, like many reptiles experience, but its feathers having grown paler. I think that would look really cool in a proper circumstance. You could use the contrast effectively within a composition. Erythrism is increased reddish coloration that can be produced by both genetic mutations and as a dietary side effect. Many mammals appear strawberry-colored when experiencing erythrism, while non-fuzzy animals have a more strongly pigmented appearance. Reptiles are rarely erythristic, but birds often have erythrism through their diet. The most famous example is flamingos, which are naturally gray, but through their diet of brine shrimp and algae, they retain the reddish and pink pigments. The same is true for roseate spoonbills, and is also the case for that one paleoart meme of Pterodostro, which I can't blame, because of course it's gonna look pink. Like, I can't imagine it any other way. A more intriguing example, though, is that of the Baltimore Orioles in southeastern Canada. A study in 2013 found a relationship between a more increased rate of erythrism and the introduction of Leucism shrubs, which are bush honeysuckles. And I think that if you want to incorporate some ecology into your paleoart with dietary effects, find some sort of plants that have red, maybe fruit or seeds, and then you can show, like, herbivorous or even omnivorous animals having erythrism as a side effect of that. I'm going to start speeding up for these last two because we're going to be here all day. Xanthochromism is a similar mutation to erythrism, but instead of red, it's the hyperproduction of yellow pigments, or the absence of red. This I haven't seen talked about at all, but it's been observed in various birds and reptiles, so it's possible in dinosaurs, obviously, because, you know, phylogenetic bracketing. Axanthism is literally the opposite, where there's way less yellow produced and the animal looks bluer. And I've only really seen this in frogs, if you look it up, but it sometimes happens with reptiles and birds, so you can try it. Like I mentioned with Melanism and Albinism earlier in the video, many of these conditions can be partially expressed. In my Montosaurus video I did like 5 months ago, oh my god, I made the individual partially leucistic. This is something often called being piebald, and the most common example I could think of are those cool looking ball python morphs. There's a lot of creativity to be had, so just go wild with it, honestly. Another thing to consider is interspecies differences in coloration. I know this might seem obvious, but when talking about prehistoric life, many people think that things like Triceratops or Stegosaurus are species. In actuality, these are genera, and each have more than one species, with exceptions of course. For this, we should consider the sheer diversity in modern species, even among closely related animals. Some are hard to tell apart, like the 2 species of Ophiodrys greensnakes, and other morphological and behavioral cues are better to distinguish them than simply color. Some of the most clear examples of modern dinosaurs having different colors among species in the same genus are macaws, with the scarlet macaw and blue and gold macaw looking vastly different from each other, and buntings. I mean, just look at an indigo bunting, a lazuli bunting, and a painted bunting beside each other. But of course, this brings up subspecies, which are an even more narrowed down delineation within species. Subspecies cannot really be reliably confirmed in fossils, and they're only really understood through genetic data, but in wide-ranging animals, their appearances can be drastically different. The most dramatic example of this I could think of is that of the common garter snake, Thamnophis sertalis. There are several subspecies that belong to this very widespread North American colubrid, and many of them look vastly different from each other. Just look at the eastern garter snake, which I have experience with because they're the most common snake in my area, and then the red-sided garter snake, which lives closer to the Midwest, the maritime garter snake, which lives on the East Coast, the California red-sided garter snake, and the San Francisco garter snakes. Again, there isn't really a solid way to confirm a subspecies within an extinct species, but wide-ranging animals do tend to have them, so it can be a fun bit of speculation to consider. Finally, what I want to consider are morphs separate from the mutations I discussed earlier. These don't really have any fancy names, but are more so just like color differences people have noticed within certain species. Morphs occur in animals with wide ranges, but their appearances are inconsistent in many cases. This is a Decay's brown snake from the genus Storaria. They're small fossorial snakes that I find decently frequently, and they're very fun to interact with. Here's a few of them. They look very similar across the board, with some variation here and there, but nothing overall too noteworthy. Now this is its very close relative, the red-bellied snake, also in the genus Storaria. And here's another one. And another. There are 3 distinct morphs that I've observed, all in the same area, and in the same species. This is an eastern milk snake, a subspecies of Lamprepeltis triangulum.
Is it pretty?
Here's another.
Gorgeous. Ow.
Again, they don't look the same. Morphs can occur for a multitude of reasons, mostly being biome-related, but these snakes were all found in similar or exactly the same habitat to their compatriots, and yet they look different from each other. I haven't been able to find too much on these 2 examples, which I find personally interesting. This paper here argues there are only 2 morphs of red-bellied snake, but here we are with clearly different phenotypes, and I'm not the only one who's noticed this, so I'm clearly missing something here. For the milk snakes, it's very likely that this is because there aren't any venomous tricolored snakes in Ontario, and so being too brightly colored would just give them away to predators instead of being an effective warning. This can be corroborated by a greater number of red morph milk snakes that look more like coral snakes as we get closer to coral snake territory in the south and southeastern US. Red morph milk snakes aren't absent here though, and this sort of in-between morph is the one I've seen the most. With different dinosaurs, if we know of examples with largely varying habitat types within, this should almost certainly apply, at least in some cases. This could apply to small taxa in particular, as larger ones seem to have less distinct morphs over large distances, although there are of course exceptions to this. And now with all of that out of the way, we can finally get into my final artwork. Take it away, live action me.
Hello there. I'm thinking I'm going to do some rutting Pachycephalosauruses. And the reason I'm thinking of doing that is quite simply because I made another community post a few months ago and I didn't do it because I forgot about it. I'm thinking some very colorful Pachycephalosauruses, some Erythrism here, some Xanthochromism here, some Melanism there.
I recorded that on June 9th, and it is July 16th, so yeah, sorry guys.
Alright, so here is the sketch. You may be wondering, wow, this is messy as hell. It looks like they did it without planning. Shut up. But Pachycephalosauruses are very weird to draw. Now time to do the actual fun part. And that's the end of the video. Thanks for watching, guys.
So this painting actually turned out to be a huge pain to do, and you'll see that as this video goes on. It's quite significant in that I think it's the first crowded painting of dinosaurs I've done. Usually there's like a max of 3, like the Pyroraptors I did, but this one is like a whole crowded scene. The problem is I didn't go in with a plan. I kind of just slapped everything down. That's why I went to paint super quickly. It took a long time to do. Unfortunately, most of this work you're seeing me doing is gonna be removed in the future. The center Pachycephalosaurus, the yellow and blue one, is supposed to be the standard morph of Pachycephalosaurus, and what I'm really doing in terms of references was I referenced, or at least at some point I referenced a Euromastix for the body, and for the head I looked at eastern fence lizards, weirdly enough, because their bellies are like bright blue. The orange I just added there because, you know, orange goes with blue, but I get rid of it. It doesn't work out too well. Another thing I did wrong in the start was perspective. It's why I painted over those packies back there. It just didn't look right.
Quickly addressing the discrepancy you'll probably see in a bunch of these time lapses where I just randomly jump to things showing up, like the blue on this Pachycephalosaurus with the trees here, and my phone is like, "You're out of storage, buddy." And this video is probably not gonna help because it takes up more storage than time lapses. What am I doing? So I was like beating myself up over, hey, why does the blue-headed Pachy not look right? It's in the shadow, but it still just looks so flat when I do that. I was a dumbass, but it's supposed to have more value differentiation. Okay, so the lighting still looks off to me. So what I'm gonna do is probably what I should have done from the very beginning, which is make a model to reference the light off of, specifically for the heads, because that's probably the hardest part to actually get right. So I was planning on spending more time on this painting tonight, but unfortunately I had to do my university course selections, which was very complicated and confusing. So thanks to Evan for putting me through that. Like, why can't it be done already, man? Why do I have to keep going back and making things harder for myself? Like scales? Individual scales? Are you kidding me? Guys, why is it that friggin' Liquitex has to be glossy? Why does it have to be so glossy? It's because it's always shining. You guys can barely see what I'm doing. That was extremely painful. Holy shit. But I wasn't happy with it. And it was just bothering me a lot. In fact, this whole animal, it seems out of perspective. The Erythristic Pachycephalosaurus's body has been bugging me this whole time. The head looks fine, but the neck is a bit off and the body looks super weird. So instead of doing that, I'm just gonna cover it with a rock. I worked a little bit on the on the blue Pachycephalosaurus off camera, and now I don't know how to make the color scheme work. Oh, I should have planned this out so much more. And besides this package, which I actually do like, I'm not happy with anything here. This is actually so bad. Also, I just realized I would have been so much smarter and more thematically fitting if I had, I don't know, painted something that we already knew the colors of. Like if I had done different variations of Anchiornis or friggin' Sinosauropteryx or even Borealopelta or Psittacosaurus. Psittacosaurus would have been a godsend because you know pretty much exactly what it looks like. That would have been smart. Look at all the paint on my arm. Also, why is the lighting better like this? You can actually see it a lot better here. So you got the Erythristic, the Xanthochromistic, and I was planning to do a morph of this. This one would be in a more orange-brown with a purpler head, maybe some stripes. I don't know if I'm going to keep this one in. The whole morph thing is what started me on this rabbit hole, so... But I'm also at the point where I'm so tired of this that I don't know why I forgot to start filming, but I just thought of a great idea. If I just put some watered down really light blue and just splop it all over here, then I can make it look like fog or mist. And then I have an excuse to be less detailed and finish this faster. I'm a genius. Oh boy, the worst part is it actually kinda worked. So, this is the final artwork. Am I happy with it? No. Am I despising it? Also no. I think it's okay, and I think it's a lot better than my Lambeosaurus artwork. You can kind of see which parts I took extra care with, and then the fog and mist kind of just was a half-assed way of getting this over with when I started hating it. But that made me an excuse to make these two in the back almost not visible at all. But let's call it a creative decision. But Pachycephalosaurus in general is not a very complete animal, and it's shrouded in mystery. Mystery. I'm sorry. I am so sorry. But if you enjoyed this video and want to see me do more weird paleo art question type things like this, because this has been something that's been on my mind for a while, please tell me in the comments, and feel free to subscribe. I don't really know how to end this video. Imagine if I just cut it off halfway.